Now that we've talked about distance and midpoint, we'd like to talk about circles. A circle is a set of points in the plane that are located from a fixed distance. This fixed distance is called the radius from a given point, and the given point is called the center. On my picture of a circle here, the point in the middle is the center, and the fixed distance is the radius. And one way to visualize that is to connect a line from the center to any point on the circle, and that distance right there is a radius. So the circle is just all of the points that are located the same distance from the circle. All these points here, and there's an infinite amount of points on your circle that are all located the same distance away from your center. Putting all those points together, you get your circle. So I would like to find out what the equation of a circle in relationship to the x and y axes. So if I'm given a point on the x and y axes, I need a center. I'm going to use the letters h and k for my center, and I need a radius. And my radius, I'm going to use the letter r, which stands for radius. So when I'm looking for the equation of the circle, I need an equation that relates all of the points on the circle to h and k, my center, and r, my radius. So I'm just going to pick one point here to represent all the points, and so these are going to be a variable, the variable x, comma, y. And I'm going to try to find a relationship between the hk, which is a fixed point, and the x, comma, y, which are variable points, meaning they could be anywhere along the circle. I know that the relationship is that the distance between them, or the radius, is a fixed distance. Now notice I keep using that word distance. Because I'm using the word distance, I'm probably going to be using the distance formula, which is what we just talked about. So using the distance formula, I can relate the distance between the first point x1, y1 and the second point x2, y2. Well, to relate that into our circles, I have 2 points and I know that there's a distance r between them. So I'm going to substitute, instead of my d distance, in this case I'm going to use r for my radius. For my x2 minus x1, I'm taking the x values and I'm subtracting them. Well, what are my x values in this case? Well, I have the green x, which is my variable, minus, because there's a minus in the formula, my x coordinate of my center, which in this case is h. Plus we also have my difference of my y's squared. The y's, when I subtract them in this case, I'm going to use my variable y minus the y coordinate of my center, which in this case is going to be k. This is now relating x and y, my variables, with h and k, the center, and my radius. Next, I'd like to get rid of the square root by squaring both sides. This will also help us to get us both sides of the circle. So I'll get x minus h quantity squared plus y minus k quantity squared equals r squared. And this now is the equation of a circle in standard form. X minus h quantity squared plus y minus k quantity squared equals r squared, where my hk is the center of the circle and r is the radius of the circle. If you had a little bit of confusion about how we derived the equation of a circle, that's probably okay. All you really need to know is that this is the formula for the equation of a circle in standard form, and you need to know the center is hk, and you need to know r is the radius. Once you have this piece of information, you probably don't necessarily need the derivation, although I find some students find it helpful to see where these formulas are actually coming from. It helps them to memorize it. Either way, you need to memorize your standard form of the equation of a circle. There are 3 types of things that we'll be asking you to do. The first is, if I give you a center and a radius, I need you to be able to write the equation. So if I give you my center is 2, -1, you might consider labeling your center H and K. My radius is 4. And all I'm going to do is plug it into my formula. I'm going to rewrite the formula just so you can see it a little bit closer here. Notice that there's minuses in the formula because the minuses came from the distance formula. So when I plug my values in, I'm getting x minus h, minus because there's a minus in the formula, h is 2, squared plus y minus because there's a minus in the formula, k, which is -1, squared. Notice a minus because there's a minus in the formula, and negative because k is negative, equals r, which is 4, squared. Well, no one really writes minus and negative. We always write adding a positive, and some of you probably can do that in your head on the first time around, and that's fine by me as well. On the radius squared, 4 squared is 16, so please reduce that as well. And that is your circle written in standard form. Please do not distribute out the x plus 2 quantity squared. This form in standard form actually gives you a little bit more information than if you distributed it out. In fact, a little bit later on, we'll be taking a distributed equation and we're going to be factoring it and completing the square in order to put it into standard form. So please don't bother putting this in another form. On the next problem, I'm going to locate my h and my k from my center. My r in this case is 3. I'm going to write my equation again. You probably don't need to write it every time, but I find that it's a little helpful. X minus h, and in this case my h is a -3. Some students might right off the bat change that to a +3, and that's fine by me. Plus y minus k, but k is now 5 squared, equals r, and r is 3 squared. When I take the x minus a -3, that's really adding a +3. So I have x plus 3 squared plus y minus 5 squared equals 3 squared, but 3 squared is 9. And that is my equation of this circle with the center -3, 5 and a radius of 3 in the standard form. The last problem, I'm given an hk, and this time my radius is the square root of 5. May look a little bit more difficult, but it's no harder than the others. We still take our information and substitute it into the standard form of the equation. X minus -4. Minus because there's a minus from the formula, negative because there's a negative on the 4. Squared plus y minus k, but k is 2 squared, equals r, which is the square root of 5, squared. To simplify, subtracting a negative is the same thing as adding a positive, so I get x plus 4 squared plus y minus 2 squared. And the square root of 5 squared, the square and the square root are opposites, and so they cancel each other out, and I'm just left with equals 5. So that's the first thing that you'll be asked to do. Given a center and a radius, you can now find your equation. The next thing you might be asked to do is to graph it. So in order to graph a circle, I want you to determine the center of the circle, which in this case will be h and k, and draw that point on your graph. Next, determine the radius. If you're not given the radius and you have to find out what the radius is from the equation, you may have to take the square root of the r squared term in order to find r. Next, I'd like you to move up, down, left, and right r units from the center. Then I would like you to connect the points, giving it a circular shape. So let's practice this. The next set of problems says graph given an equation in standard form. I'm asked to get the center, the radius, and give me the picture. I'm going to rewrite my equation in standard form, just so it's a little bit closer here. In this case, my center is found by getting the h and the k. Well, the h is the opposite of whatever value is next to the x. Because there's already a minus in the formula, my h in this case happens to be positive 2, because there's already a negative in the formula. Because there's a negative in the formula next to the y, I need to take the opposite of positive 3, which is negative 3. My radius can be found by taking r squared, which is 16, and taking the square root of 16, which is just 4. So I have found the center. Now I'd like to plot the center on my graph. My center will be at 2, negative 3. I found my radius by taking the square root of r squared. And then I would like to move up, down, left, and right r units from the center. So from my center, I'm moving up 1, 2, 3, 4 units and put a dot. Go back to your center. Move left 1, 2, 3, 4 units. Move down 1, 2, 3, 4 units. Move right 1, 2, 3, 4 units. Now I know this only gives you 4 points, but I can connect these 4 points, giving it a circular shape. Here's a nice shortcut you can use to try to get a nice circular shape. On the 4 green points, try to put some arcs. And once you have those arcs, then you can kind of come in and fill in those arcs. And you can get a pretty good circle. And that looks at least like a circle. One common student mistake is they'll take these points and they'll kind of connect them just only around right at the corner, and they'll get something that kind of looks like a baseball diamond. Please try not to do this little baseball diamond. That is not a circle. We want to make it nice and round, so try to use your little arcs. Let's look at the next problem. X squared plus y squared equals 49. Well, I would like to find the center. Well, notice there's no parentheses here at all. So I'm not subtracting anything inside the parentheses with x. I'm not subtracting anything inside the parentheses with y. Another way of thinking about this problem is x minus nothing squared plus y minus nothing squared equals 49. There's nothing inside the parentheses with x. Notice we just don't write the parentheses if there's not anything inside the parentheses. So my h would just be 0. Notice there's nothing inside with the y, so that would be kind of considered like a 0. So we have my center being 0, 0, my h, k. My radius is found by taking the square root of r squared, and this r squared is 49. The square root of 49 is 7. I can plot the center on my circle. It's at 0, 0. And then I'm going to go up 7, down 7, right 7, and left 7. Please do not try to connect this with a baseball diamond. I see a lot of students, they'll connect straight lines and then they'll just all try to make a little circle there. That's no good, okay? Try to make nice big fat arcs on your 4 points that you do have, and then the rest of the points can kind of just be sketched in. It doesn't have to be a perfect circle, it just can't be a baseball diamond, alright? On our last problem, we have x plus 3 quantity squared plus y minus 5 quantity squared equals 20. So my h and my k are found by taking the opposite of the value next to the x, which is negative 3, comma the opposite of the value next to the y, which in this case is positive 5. I can plot negative 3, 5. And now I'd like to find the radius. Well, the radius is found by taking the square root of r squared. And the r squared in this case is 20. So the square root of 20, well, I can break that down. That's the square root of 4 times the square root of 5. And the square root of 4 is plain 2. 2 square roots of 5. And if we type that in our calculator, we would find out that that is 4 point some value. Another way of thinking about that is, you know that the square root of 16 is 4. You know that the square root of 25 is 5. So sandwiched in between 16 and 25 is 20 somewhere in here. Notice that my whole values skipped right over the square root of 20, so I have 4 point some value. I don't even know what that value is. I could get a calculator and find out a little bit more precisely, but I really don't care at this moment. I know my radius is 2 square roots of 5 and in an exact form, but I can't use that form on my picture. What I can use is 4 and a little bit. So from my center, I'm going up 1, 2, 3, 4, and a little bit. Notice that's between 4 and 5 units away from my red. 1, 2, 3, 4, and then a little bit. To the right, 1, 2, 3, 4, and a little bit. Left, 1, 2, 3, 4, and then a little bit more. So as long as it's between the correct two numbers, that should be sufficient enough to get you a good graph. Connect your points with a circular shape. And we have our graph of a circle.